Hi, welcome to the TST Roundtable. Today is February the 20th. I'm all confused. 2013. And today we got a special guest coming on, or tonight I should say, and that'd be Dan Sullivan. This is his book, and it's on VD, voltage drop. We've done some videos. If you haven't seen the stuff that we have on our YouTube channel, you can go to TST Seminars on YouTube and type in voltage drop. So we'll be interviewing Dan, and Dan is the inventor of the LoadPro, so you can pick that right up there. And the LoadPro is a neat tool that connects right into a voltmeter to do a voltage drop. And of course, we're always here to take your questions. Apparently, there's quite a few of you that are new to coming onto a webcast and forgot to click on. So I'm going to look up there and see if we have other people going on. We have myself, I'm G. Trulia. We've got Rich Peterson, Pierre Rispo, Bear or something.
Bear Smallburger.
I forgot your name already. Eric something or another, and Basil something or another.
There you go, it's easy.
And in the back we have Adam Varney.
Yeah.
So we're here to interview him, and I'll remind you, tomorrow night we'll be doing the break webcast with Motor Age. That'll be out in the shop on a vehicle, so you may want to tune in tomorrow night, the 21st, and Pete Meyer will be here, and I think Mr. Pierre will be here as well. So let me see what we got going on up there, and maybe you guys, Rick, why don't you talk a little bit about that tool? Give people some...
LoadPro is a very nice tool. It'll actually put a load onto the circuit. You can see the voltage drop. You disconnect your component, put it on, put the leads on power negative, hit the button and watch your meter reading. If it drops, you have a resistance in one side of the circuit. Then you just reverse it, either power or negative, to find out what side it's on. It'll tell you how much of a drop it is right in the meter. It's a neat little tool. I used it quite a few times already, and it works great.
Hey Adam, could you speak off your computer?
No, but I can't hear anything out of my speakers either. It's all quiet. I can see the video.
Now, this book is not only on voltage drops, it's on fundamentals of electronic troubleshooting. It's got a lot of literature, easy to read. It's all handwritten by him. A lot of diagrams. He keeps it simple, which a lot of people like. You know, obviously we need to keep it simple because it's so confusing in today's automotive field to diagnose stuff. So the easier it is to understand, the better. I read throughout the whole entire book, and it's a very nice read.
You mean even you understood?
Even I understood.
See, there you go. And there's pictures.
And there's pictures.
The key thing here is, unlike just doing voltage testing, this actually places a load on it. So if something's got, if you have a 20-strand wire and there's only 2 strands left, the voltage is going to be the same until you put a load on it. And then as soon as you put a load on it, the resistance from those missing strands is going to show up as a massive voltage drop. That's the idea here. You're actually making it work so you can find the flaws.
Eric, you've worked with this, right?
Yes.
Have you ever been able to determine the exact load that's put on the wires in amperage?
No, I use amp probe for that. I mean, you use Ohm's law to find that out.
No, as far as what kind of a load does it put on the circuit?
It tells you in the book. I don't know exactly.
It tells you in the book. Okay. All right. Okay.
I can find that.
And that's something we could ask him when he gets on. He should
Right,
be on in a few
absolutely.
minutes.
Absolutely.
And maybe we have some guys out there. Anyone using the LoadPro out in the internet land here? Now we got one guy with his hand up. Another guy.
Okay.
Oh, Williams, I know that.
That's
I
good.
do. Oh, a lot of
That's
them. And it says 0.5, Jeff tells us 0.5 amps.
500 milliamps on the
500
circuit?
milliamps.
All right. Okay.
So that's pretty damn good.
All right. Of course, depending on the circuit that you're using, that you're testing.
And we got Dan Sullivan coming on, but go ahead, don't let me stop you.
Okay,
there.
good. That's good. So let's, but you got to remember something, that voltage drop in any of the circuit's going to create problems. All right, and it can cause anything from interference to anything working,
Hey, I'm here, but
Oh, there you're on. You're on.
He's on.
I got to get you off the phone. You're on.
And we, on the speakers?
Okay,
So we can't hear ourselves. but we
Okay,
can hear
Dan, just hang on one second, Dan, so we can get this straightened out. So for everyone that's on the internet, our guest speaker is on, Dan Sullivan, and we're gonna have to cut down the echo, so Pierre is gonna play with it in the back. And Dan, why don't you just say hello to everyone, and then we'll get going with the interview.
hey, how y'all?
All right.
Okay?
Make
Get that
sure-
up just a little louder, Pierre?
Make sure everybody else is hearing
Okay,
them too.
that's good.
You
Make
guys,
sure-
am I, audible?
Yeah, sounds good.
You're audible?
Sounds good.
You're audible here.
Okay, so let's ask the people out there on the internet, could you hear Dan? Dan, we still have no video for you for some reason.
Again, the camera's grayed out again, G. Same as it was earlier.
Huh. Let's
All right,
see.
so apparently we just have his audio.
Let me
For
get-
those of you waiting for us, this has been our life with WebEx.
I can hear you guys now.
Now you can hear.
Oh, now? All of a sudden now?
Really?
It's in and out. It's in and out.
And now I have no camera for Dan. Dan, can you hear us? Oh, there you go. Ah, so there's Dan, everyone out there. You don't need to look at us, and God, you can if you have enough of us. Thank you for your patience again. You know, we've done so many of these. We didn't do anything different. It's working, not working, but anyway, we're on there now.
Yeah.
And Dan, we gave you a little introduction. We held up your book and the LoadPro, so we had that up there. And let's ask you about this. What made you think about coming up with this great invention?
It was an accident, because the student asked me a question I couldn't answer and made me mad. The short version of the story is I was teaching how you can use Ohm's law by measuring amperage and knowing the resistance and doing the math and blah, blah, blah. And a guy came up and said, I don't have an ammeter, how do I do it? I don't know. And it actually occurred to me, I'm probably going to lose half the audience, but it occurred to me in a dream, and I actually still have the piece of paper that I drew it on a Tuesday, and I found it on a Thursday, built it Thursday night, tested it Friday, and it worked. It was a complete accident. Maybe there was a small amount of inspiration, but the circumstances were very odd. And I consider myself extremely lucky. I don't attribute any particular intelligence to this other than just recognizing it when I saw it. But it's such a simple thing. I mean, anybody who's used it knows how simple it is. I was just telling the guys downstairs from Snap-on that it does not require prediction. And one of the things that I've noticed about technicians is the mechanical way of thinking is I need to know the answer before I start. And electrically, you can't do that. It's impossible. And the problem, though, is that they still try. And when they do that, they commit. When they commit, they can usually commit to a wrong direction. So the beauty of this method, and the tool works with the voltmeter and reading the meter better, this method does not require prediction.
Dan, let's go over that. I'm sorry to interrupt you. Let's go over that. You made this tool, and let's explain to everyone, in case they don't know what a LoadPro does, what does this tool do?
Well, the digital voltmeter by itself cannot see corroded wires because I tested a Fluke 87, and the Fluke 87 will actually read normal 12 volts for about 740,000 ohms of resistance. So any corrosion in the circuit is going to be invisible to a meter that's only reading open circuit voltage. This tool adds the last step by allowing you to turn the circuit on while you're reading voltage. So you're doing two things at once. You're reading voltage and turning the circuit on. And then that turns the reading into a voltage drop just by pushing the button. So
in other words, you have resistance that's built into the LoadPro, so you're making the circuit work to do a voltage drop.
Correct, yeah. Because the biggest concern that a lot of people have is you don't want to damage the wiring, you don't want to damage the connectors, but anybody who understands voltage drop knows that you got to keep the load in to do one. Well, that problem by allowing you to pull the load out, the light, the horn, the buzzer, the beeper, the pump, the motor, whatever, you pull it out. And since 80% of 80% of electrical faults occur in wiring, the ability to test the wire completely and succinctly and accurately with one voltage test is a pretty powerful method. So it takes the guesswork out by allowing you to load the circuit without the component installed. No junk wires, no disconnecting thing, no on meter, no. You just plug it in, read voltage, and you know an answer.
Okay, we got a couple of questions here. One guy says, what is the value of the resistor inside the LoadPro?
The original was 100 ohms back when the whole 42 volt, thing happened. And the current load is, I was going to write it for you, it's 40 milliamps per volt, and it's a 25 ohm resistor. And it's effective down to about 1 ohm, because 1 ohm will give you a 4/10 of a volt drop. So any drop is measurable, and if you have any drop that's greater than 4 to 5 tenths, it means you have something there, and then you have to determine whether it means anything by virtue of what you're actually testing. An AC clutch is going to have a different threshold than a relay. But it's 40 milliamps per volt, 25 ohms, and it's rated 20 watts. So the tool is useful up to 28.5 volts without any danger at all. And it's good for 5 volt and 8 volt systems. We tested them on cats. Guys, you can't ask for that, so that's in the manual. And it will work for 5 and 8 volt sensor drivers without any problem.
Very good. I mean, I've used this tool and I think it's very, very handy, as well as Eric over here uses it as well. It's a good tool to help technicians if they're having an issue with voltage drop, not understanding it. Just hook it up to a meter, press the button, load the circuit, and see if you got a drop. Pretty good. Great setup.
Okay.
So what else can you tell us about it?
Well, let me back up half a second here. I'm used to doing this on a video camera, so I'm used to good. The important thing that everybody out there needs to know is that there's a better way to read a meter. Okay, and the meter on DC volts is going to jump around. Oh, I put those guys downstairs manually. First of all, I prefer auto ranging meters, and don't take them off auto. Don't go click, 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 beep. Don't do the beep. The meter is going to read just those voltage readings. And everybody needs to understand that the meter's not broken. The meter's telling you that you have an open circuit. Not predicted, not anticipated, but it's factual. It's absolutely infallible. This reading means you have an open circuit. Okay? So if you're reading voltage and you see that, you know it's an open. All right, well, if I take the leads and put them together, notice that the meter goes to 0. All right, and if you lead it, and if you jump around like this, it stays at 0. Well, that's a short to ground. Okay? So the real advantage of the tool is that a tech can go out, turn something on, read voltage, and immediately have an answer that does not require a prediction that is infallible. And I didn't start out being able to say that. That never occurred to me at the time when I invented this thing, but that's what it's come to be. So the tool obviously has that function. But the other neat thing is you can stick the tool in, for example, to a fuel level sender. And the 25 ohms is roughly equal to the 33 in a lot of senders. If you load the circuit while you have it plugged into the fuel level sender connector, it'll actually make the gauge sweep. You can watch whether or not the gauge works. The other cool thing is that we have what we call the steady pin tip.
Yes.
And it actually will sit on top of, it's a ballpoint pen, it'll sit on top of a connector in a pin or ECM slot, and it won't fall off, so you get a much better purchase on the connector. And in that dark hole with the meter on your chest, this is kind of a nice feature. So those are the primary advantages. But, we've actually had a guy teach me how to use it on, CAN bus systems in J1939 data links, but what he did was he joined all the loops together. Took voltage on one end, it looped back around, and then voltage at the other end. No drop, he knew the CAN bus data link was fine.
That's a great idea.
It is.
And I didn't think of it either, so I'm very grateful to him.
Okay, Dan, let us interrupt you for a minute here because we're getting bombarded with some questions. One of the questions is, where can they purchase it?
Okay, well, this one that I have is the Blue Point version, so that's obviously available in Snap-on truck, but it's available on all the other tool trucks as well, plus it's available online at various places. If you just type in LoadPro leads, then the Google or whatever, Google will come back with a lot of them. So there's a lot of different places. I will say that I don't have a favorite place, but the guys out at AES Wave in California.
Now, our buddies George and Carlos.
That's George. They were the very first people to adopt this and start marketing and selling it for me. So I'm very loyal. They're competitive, but there are a lot of other places out there as well. So that's.
Now, another question, Dan, is what's the cost, roughly, the list price, we should say?
They're available for as little as $45 online, and Snap-on has them for $77, I think. I can't get involved in a buyer's decision where to buy it, but I made that guy who licensed it, Steve White at Electronic Specialties, I made him promise that the price would never go above an hour's worth of labor. So the tool was always going to be affordable for everybody, because I think that's important, and it's certainly less than one billed hour, which I think is
Now,
which makes it very convenient.
Now, we got a couple of people saying, make sure you demonstrate the tip.
Oh, that thing again?
Never tried to demonstrate.
And by the way, you know, everyone that's on, if you want, hang on a minute, Dan. Everyone that's online, if you want to make your picture bigger, double click on Dan's picture. That'll make it full screen. So if you double click, you'll be able to see Dan a lot better than a small picture. So there's his tip.
I don't want to see a lot better, but okay.
Can you see it?
This is what, I think this is what they're talking about. This
Yep.
is the steady pin tip. And I don't know if we do it in the temple.
Yeah, you can see it's like a hole in the bottom of it.
Yeah, it's cupped.
Yeah,
It's cupped.
Concave,
yeah, like this, concave. Yeah, that's a good word, concave, I like that, okay.
exactly.
Yeah, and that just basically, it's just there. I'll be honest with you, I don't like poking holes in wires, and this was sort of a backhanded way of making that not possible, and the tip just became really popular.
And we like you for doing that in the snow area, you know, with the salt and corrosion. I know my friends in Arizona don't care, but I care.
Yeah, oh yeah, yeah. Well, everybody at Milton Cat, anybody who's in the New England area, everybody at Milton Cat uses it. If anybody's in Ohio, Cozen Construction, the entire company uses the tool. Southwest Airlines uses it, SkyWest Airlines, Air Wisconsin. So the tool's beginning to make some headway, which is very flattering. And it's just the right way to revolt it.
That it is.
How long have you had this tool at ASC Wave? I mean, how long? AES Wave. It's been out for quite a few years, hasn't it?
I think Carlos called me in '06, maybe '07. I'm not really sure. And that was when it was yellow, and it was called Test Light, and now the new license, they changed the name of it to LoadPro, but these were originally the Test Light voltmeter leads, they were yellow.
Yes, they were yellow.
And,
That's the one I have.
Significant number of those, I guess, to keep it going. I think the tool in its original Test Light version with the handle was probably 2006 or 7, and that's pretty much when Carlos called me from AES. The tool was patented in 2002, and I've been at this for 13 years.
Wow.
So thank God for keeping it up.
Yeah, it's great when we see someone in our own industry that works on vehicles come out with something to help a technician save time and do the job right.
Yeah, electricity is tough enough, and we don't need to make it tougher. And, gee, we were talking a little while ago about, the idea that we need to get a standardized diagnostic protocol, because there isn't one. And when you think about it, why do we need 47 different ways to find an open, short, or high resistance fault? That's all there are. So there should just be one way to find it, because all circuits are basically the same, all have one load per circuit. And I don't care who the manufacturer is, it's a stinking headlight. Let's figure out how to, diagnose the circuit without having to go through all these hoops.
That's true. One of the things Pierre and myself, we sat on the old STS board, I'm the past president there, and Pierre was a board member. And one of the things we were trying to get passed through was actually, getting a standard for what technicians would really need as far as training or what tools would do certain functions.
Right.
Pretty hard to do. It seems like in our industry, people are all over the place.
Well, this, I have to keep dragging myself back to humility because I know how I sound, and I'm really not a very good salesman, a much better teacher. But when you start to consider what this method, and I'm going to stop calling it a tool, it's the method. It's the method of voltmeter only diagnostic. I want everybody to listen. Okay, I'm going to. Some of you guys, you're going to hear something you've never heard before. Okay? I'm going to teach for a couple minutes. I have a question for anybody who cares to answer. If you go out to a component, you pull it out, you turn it on, it should be running, motor, I don't care, solenoid, whatever. If you read system voltage at that point in the connector, what does that system voltage mean to you, the guy, what has to fix it? What does that 12 volts really, truly mean? And I'll give you guys a second if you guys want to respond.
1/3 of the puzzle.
What do you think it is?
1/3.
Yeah, that's right, 1/3 of the. To me, just while people might be typing in, to me it means my supply side, if it's indeed system voltage and doesn't have a big drop, my supply side is functional.
Right. Well, don't forget, I've got the ground lead in the connector too, because nobody builds single wire components anymore.
Yes.
Right.
So, yeah, the comment about the voltage drop is critical, but the question is, what does the 12 volts mean? What does it actually mean?
To me, if the component is working, if it's putting a load on the circuit, it means that I have good feed. That's all it means to me. I have good supply. And I have to look at whether the component's drawing what it's supposed to, and I have to make sure that the ground's not floating or I don't have a ground problem.
Okay. Did anybody type an answer in?
I couldn't hear what you said.
Did anyone type an answer into that? I don't believe so. We're looking now.
What was the first?
Answer to his question.
Did anyone type
I
any
don't know
answer?
what the question was.
Well-
So I don't know. There's a word that says nothing,
Nothing. Means nothing, yeah. Okay.
but I don't know what.
Okay,
That was it.
let me show you guys this. The interesting thing about it is, I don't know where that. If there are only 3 faults, open, short, to ground, and high resistance, it can occur in a single wire. And that's it. If you guys come up with another one, tell me, I'll put it in the book, but I haven't been able to find one. What it really means is you don't have an open or short.
Yeah.
And now that may seem intuitive to some people, but it's not what the manufacturers teach. The manufacturers teach, go check voltage here, do you have it here, yes, go to the next step. They don't ever tell you that seeing system voltage in the connector is a continuity test. If you have voltage, the wire can't be broken. If you have voltage, the wire probably can't be shorted because a short to ground would probably blow the fuse, or it would at least give you the 0 volt indication. So my methodology is let's not ask what's wrong. That's the problem. Guys want to ask what's wrong, what's wrong, what's wrong. The answer is I don't have a clue what's wrong. But I can doggone sure figure out what's working right, because if 1% of it is failed, the other 99% is working. So I can identify what's working much faster and much more accurately than I can ever identify what's broken. So if you start whittling away at what is not broken, eventually you come to what has to be broken. So if I have a system voltage reading at the end of the truck, with a backup alarm or an AC clutch or whatever, my method is we rule out opens and shorts. They're gone. They're off the table forever and ever, which is 2/3 of every possible fault. You then simply push the button on the leads, and if the voltage doesn't change, then the wiring is not the problem. Now, fundamentally, the 80%, like I said, of faults occur in wiring. So your better bet is in assuming that first and checking the wiring first, rather than trying to rule out the component. So from a sheer numbers perspective, the wire's going to be the culprit far more often. And seeing system voltage rules out 2 of the only 3 faults you got, the LoadPro rules out the 3rd. That's what it does.
It's cool.
It is cool. It's pretty simple.
It's a very, very good way of thinking about it and looking at it, that's for damn sure. Dee, do we have any questions up there from anyone?
Questions.
Does the LoadPro work with all meters?
Does the LoadPro work with all meters?
Yeah, as long as you have the banana clips, we're not doing anything about non-banana plug meters, but it works with anything, with a manually ranging meter, depending upon the sophistication of the meter, you may have to flip the meter down to millivolts, which doesn't hurt it, it's not going to hurt anything, to confirm. And in a lot of ways, people get concerned about that OL and whatever. The meter's not going to be damaged if you read 12 volts on 200 millivolts, so that's not a problem. But the only real fundamental difference is the auto-ranging meter, which is the one I have, it's just pretty much there. The manual ranging meter, you may have to work at it to get it, but it is still there. I never recommend a manual ranging meter just for that reason, and it has nothing to do with manufacturers, it's just a function of the meter.
That said, I'd like to make a comment about that. A lot of guys are a little too quick, or maybe you're in low light. You have to make sure you look at your, whatever that range display comes up on your meter auto range, and where the decimal point is.
Yeah.
That's a biggie.
Because some guys get into trouble there.
If there are any teachers out there, you can put a 100,000 ohm resistor in their wiring and it makes it 12 millivolts, and if they don't catch the millivolts, they run around in circles for about an hour, and that's fun to watch. So, yeah, the units is critical, units are critical, and the value is critical, and that's why I found the auto-ranging meter just more functional in this way, because it's easier to read.
So this, to me, Dan, this sounds like this tool and having one, it really should be used more widely than it is. I don't know many techs out this way that actually have one. And of course, they're working a lot harder to find a electrical problem without your tool. Eric is one of the few guys, well, I think he's the only guy here besides myself in the room, right, Adam, you don't have one? That has one, and, I think now that you're getting it on the Snap-on truck, where else was it available?
All the other resellers, Matco, Mac, and Cornwell, and then in various places through ISN and various places online. So
Okay.
it's readily available. It's been commercially available since 2002, but the first ones were made in the garage with Radio Shack parts, and then the next one was kind of ugly, and then the third one was actually pretty cool, and then the fourth one is the one that I think we're going to probably be sticking with.
I think most of the problem with sales of these trucks is they don't display it, they don't know how to use it to sell it. So that's what I find a lot of times I go in the Matco trucks. I always say, why don't you? And I've been on their trucks and showed them this tool, and they didn't even know about it. So and I'm like, please guys, you put it. Because you also have a YouTube video that could actually run as they're in the truck.
Yeah.
To help them sell the tool, help people be aware of it. If you don't go to training, you don't know what's out there. Unless you're looking through magazine upon magazine, they look at this tool and go, what the hell is this? Something new, they don't understand it.
Tool guys, tool truck drivers don't usually know how any of these things actually work.
They just
Well,
there to
that's
sell.
actually why I'm here. I'm in Austin, and I just got finished teaching last night and tonight 25 Snap-on dealers, resellers, and I built them little training boards with. By the way, if you haven't watched it, the one videotape on YouTube that I would suggest to everybody who teaches, if there's anybody out there who teaches, is I think it's called Teaching Ohm's Law to Text Part 2. because I stumbled across this way of making circuits out of cardboard and copper foil tape that you use for stained glass. So the student can actually draw the circuit on the cardboard, the instructor can check it, and then the student can actually build it by gluing,
Nice.
putting the tape on the cardboard, and then soldering to the thing and actually building the circuit. It's incredibly cheap, and it's incredible. I did accidentally, put one in there with no opens, and it did actually burn the cardboard, but I was just doing that to prove the concept, actually. But it's not at all expensive, and it's incredibly easy for someone to just go out there and play around. But so I mean that from a teacher's perspective, I would assume that one might help them. Really, it's just push the button. I mean, if people don't know what voltage drop is, there's a problem. But you read voltage, push button. Read voltage, push button.
It's that simple.
That's simple, yeah.
Now, let me ask you another question, Dan. A while back when I spoke to you, a few years back, you were teaching different classes that you had around the country. Are you still doing that, where technicians could actually attend one of your classes?
Sure, we're actually working on regional dates right now, trying to figure that out, because most of the work I've done has been for companies, coal mines, dealers, and the like, which is a whole different market. And but we're hoping to reach more people, so we're looking for cities where we might be able to have some regional classes. My wife's in charge of scheduling, and if I say the word calendar, she materializes and smacks me in the head, so I can't do any of that.
And we know our friends down under, you'll be going down to Australia pretty soon.
Well, yeah, I mean, I'm living proof of be careful what you ask for, because you may get it. Next week is Australia, followed by Pennsylvania, Dutch country, followed by Alaska for 2 weeks, followed by something else.
Very good.
All I can really say is that to be perfectly honest, I'm a little frustrated just because Ohm's law, and this is sort of an aside, but the tool works with Ohm's law. Ohm's law can't fail. And one of the things that I believe, and I hope people hear this and maybe think, we should never use EINR ever to teach this topic, ever. Because there are no E's, I's, and R's on them either.
Exactly.
And the other thing
true.
is the equation should be volts over ohms equals amps, because volts and ohms make amps. So people don't understand the difference between volts and amps, and there's a massive difference. So if any of you guys have access, either as members of advisory committees for programs, or you just have a program nearby, try to talk to them and find out what they do, because I teach math at the end of class, and I don't teach it with EINR. I teach meter reading first, schematic reading next. Once they're comfortable with it, then the math is easy. It's a fraction. It's one division problem, and it's easy. But without that background, it's kind of hard. So I just think the whole thing should be reversed. Teach the math at the end, and then have the equation always be volts over ohms equals amps. And suddenly it just starts making sense. So that's kind of a little soapbox thing. But if any of you guys have involvement with any schools, I would suggest that you talk to them about that. Be prepared for resistance, but at least talk to them about it.
Well, it's good. I was talking to you earlier about possibly getting you out to Massachusetts, Connecticut, New Jersey, and New York for a TST group sometime in the future. I think, and we always push something electrical, because the simplest thing and the most important thing is what technicians really don't have a good handle on. And we, think this is...
I won't say it because I'll try to keep this clean, but if you put the acronym together for always something simple,
yeah, I hear you.
you get an indication of the type of thing that you really don't want to be, because you forget that.
Yeah.
And from a diagnostic point of view, we need to teach people, and we need to understand that the diagnostic term for electrical is flipped from the mechanical, like we were talking about. People need to think about this and think about it hard, because if a guy next door to me in the bay next door gets 6 hours to change a track on a 2002 machine, why don't I get the same 6 hours to work on an electronic system that just put in the pit with 6 computers on it that I've never seen before? Why do I have to have it done in 10 minutes? And the answer is I don't. But for some reason, electrical is different, and people don't understand that. The diagnosis is going to take a long time. But I guarantee you that everybody watching this right now would agree that when you actually find the answer, it's incredibly simple to the point of it being embarrassing when you have to admit it.
That's right.
So if you,
Yeah.
you know, everybody listen to this can seriously change your perspective. If you go out to the truck, boat, airplane, whatever, car, and you know it's going to be something simple, then when you figure out that it's something simple, you're a genius. But if you go out there not assuming that it's something simple, you'll be embarrassed and you feel like an idiot. So the only thing you have to do to go from feeling dumb to being a genius is to know that when you get to the end, it's going to take you 5 minutes to fix. And that sort of makes the whole work a little longer to find the answer through diagnosis a little easier to take. And I want to say something else. You don't learn during the repair. Listen carefully, you don't learn during the repair. You only learn electrically during the diagnosis. If you rush the diagnosis, if the diagnosis fails, you have not learned anything.
And you probably have the wrong answer, too.
It's bad for an individual.
Yeah.
So that's
Stumble on the right
right through my
answer.
soapbox. What do you got?
Do we have any
Let's see if we have
questions?
some questions.
There's a question here that asks if the LoadPro is safe to use on lights that are controlled by a module, interior and exterior.
Yes. The important thing to remember is that an analog light bulb is an analog light bulb. It doesn't matter whether it's in a flashlight or whether it's in a car with a module. And that module, the only difference is that instead of a light switch turning on the light switch tells the module to turn on the light. Well, when you ask it to turn on the light, it's still putting 12 volts out to the bulb, so the tool works just fine. The difference, of course, is that you're checking whether or not the electronics inside the box is maintaining a constant voltage, and or whether or not the wiring is intact. So it works fine. On active sensors, for example, on CAT, A and B are always positive and negative. So that's just a light bulb circuit. So if you're using it on an active sensor, the power supply of the active sensor is fair game as well. The only thing we tell people is it's not really designed to work on sensor inputs, but people have used it as a sensor, as a replacement sensor. And in their world, they've been able to make it work. So it does do that. Now, the other interesting thing is, I never thought about this, but this will also apply power and ground, because as soon as you push the button, you complete the circuit, but you can't blow anything up because it's being buffered by a 25 ohm resistor. So the thing may not work well, but it will work. And that is another function that somebody pointed out that I never thought about. But yeah, completely safe on electronics, 5 volt, 8 volt sensor drivers, completely every active sensor power supply. It's just not designed for inputs. That's the only difference.
I have a question for you. Actually, B was about to read one, but I'll ask mine first. Protocol-wise, what do you recommend as far as testing? Say you have a simple circuit, a light circuit with a load. You suggest testing, for example, the power side first, then the ground side, then going to the load, or do you have a specific order you like?
Well, the answer to that is really yes, because what you need to remember is that if I put both the red and the black lead in the connector, I'm testing both sides. All right, and what we have to appreciate is that, let me see, hold on a second. Draw a little picture. You guys talk amongst yourselves. Here's
Nothing personal.
I think it is. It's on the red marker. There's no red marker.
The leads need to be
All
zero.
right, if I can't draw, I'm in trouble. And there's the red marker. All right, here's the thing. If you put this in the connector, aren't you testing the entire circuit? The entire circuit with one test?
Because you're in the power and you're in the ground.
Right. Well, this is the only logical way to test it as far as I'm concerned, because why would I want the two tests to be separate when they're both part of the same circuit? So I put the
primary
red
test,
lead.
Primary test, power and ground test.
Right. Yeah,
Right?
right, your preliminary test.
You gotta remember, we're using the voltmeter. Right? So, if I put both leads in the connector at the same time, if the voltmeter drops, then there's a problem in the circuit somewhere.
And then you can do one half at a time.
Yes.
Excuse me?
And then you can do one half at a time to figure out which half is giving you trouble.
And if it doesn't drop, you have no problem in the wiring.
Then what you do is you drop your black lead,
To where? To chassis ground.
you drop your black lead to a good ground.
Yeah, to the batteries, preferably.
What happens when you drop the black lead to a good ground and repeat the test? What's going on here?
You're only testing the power side.
If the problem comes back, where is the problem?
Power side.
If it goes away, where is it?
The other side.
Polarity is critical, because if you don't have proper polarity, that test doesn't work. So my answer is I test them both at the same time because I'm lazy.
If you get the component.
If you can reach it, right? Yeah, well, that's always the problem, isn't it? Reaching stuff.
Oh yeah, I mean, this doesn't, in some ways it makes it harder because the probe is as big as it is, but at the same time, I think, it's just, those are things you have to be overcome.
Well, there's nothing to say that you can't use the probe and it has a screw-on tip. You could screw on an extension and have a wire, something that extends to that hidden location, right? Test is still valid.
Yeah,
Yeah, it's just an 832 thread, so anything you have that threads on,
there's a lot of leads that would slip off.
Yeah, sure.
The CAT has a set of spoon leads, part number 7X-1710. They fit on there perfectly and can slide in almost any spot that you need them to go in. But, yeah, it's so simple. I mean, let's put it this way. My father was a mechanical idiot, and he got it. So I knew it was going to be successful.
That's the best test, actually.
That is.
Now, B, did you have some questions or comments?
There's a question that says, this tool seems to work well with high-load devices like solenoids and light bulbs, but what about 5-volt references for sensors and circuits with built-in resistors?
I'm not sure I know the answer to that. I know that, if it's a straight 5 or 8 volt supply, it's just a 5 or 8 volt supply, so it's technically an analog load. Once it comes out of sensor, it's different, but it's, a 5 volt reference, is 5 volt.
It seems to me that as long as the wiring can handle that amount of load, which it should have no problem doing,
Right.
then you're still testing the wiring and the sensor or whatever your load
Well,
is.
you're disconnecting the sensor, that's your load.
Yeah, that's right.
Not only that, the voltage regulator in the PCM or whatever is usually, most of them are rated at 1 amp. So if you're putting only a half amp
Yeah, they
load
could've
on the
ruined it.
circuit, it's not gonna ruin it.
Yeah, to me, from the spec, it's computer safe.
Yeah, sounds
Because like you
safe.
said, you're not going
Yeah.
over it.
And at that lower voltage, you said it was, it's less, so it's only 5 volts, so you're gonna run less than a half an amp through the
Right.
circuit.
200 millivolts,
Yeah.
200 milliamps.
Milliamps, okay, there you go.
Milliamps.
Mhm.
Yeah, so it's no,
Yeah, it's
I would say,
No big deal.
it's no
Right.
problem.
Right.
Well, we actually found a fault in a GM ECM that they didn't like. They gave me 3 pinouts for 3 drivers, and the first one that they tested, the voltage dropped, and they were looking for a reason to not like it, so they said, oh, it doesn't work, the resistor's too big, and blah, 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 blah. I said, well, okay, but I went and tested it, and I went to the other 2, and it worked fine. The 5 volt stayed 5 volts, and the 5 volt stayed like 4.9. I think they were looking for a reason to not do it, and if they had just gone with the other 2 drivers, they would have seen that. And we did the calculation backwards and told them what it was, and it turned out that that was a design flaw in the ECM. And they were not happy. They were very unhappy with me at that point, so I don't think I did myself any favors. But
Engineers never like to be wrong.
so
Now, let's talk about your book a little bit, that, I'm not sure if it comes with it or it's extra.
You buy it with or without, that's how I did it.
Oh, it's sold with and without, Dan? The
Yeah.
book? The book has some real good stuff that you have put in it.
You even had recipes which I used. Nah, I won't get it. I knew you were laughing when I got to that page. I'm like, you gotta be
You
kidding.
got to make his mark.
His wife must have really pissed off at him. That's what I said.
Hey guys, that recipe works. And
I know.
It got me through a lot of school and some dates, so.
Yeah. That's why I had to laugh when I saw that.
Now, another question I have for you, Dan. Do you have a YouTube channel? I know you have some YouTube videos. Is there a channel?
Yeah, it's Dan Sullivan.
Oh.
Dan or Daniel Sullivan. You can just put a search for LoadPro in there and the channel pops up.
I've actually watched a very easy
Yeah, I've
video.
seen some of it, but you know what? We need to link our TST YouTube channel to your channel. I'll
Sure,
try to get that done. That'll be pretty good.
sure. Happy to do it.
Yeah.
Yeah, I got a little crazy. I bought a GoPro camera and I mounted it in my hard hat.
No, that's cool.
Yeah.
I got one of those. They're the best.
Yeah, I call it helmet cam, and it's sometimes it works, sometimes it doesn't.
Bernie
but,
is that, and,
you know, what the heck?
yeah.
Gotta be
Extreme.
happy. So, yeah, I'm doing a couple more next week, no, week after, and then I'm actually gonna do one on fraction. I know it's gonna sound crazy, but one of the biggest problems a lot of guys have is they don't understand fractions. They're pretty easy to understand, so I'm gonna do a math video, actually, to teach guys and their kids how to do fractions, because they're so critically important. But I'm still experimenting, I'm still trying to figure out how to do it, but I'm slowly, I think, improving, and with luck, I'll be doing it more in the next couple of years, so.
Cool.
Been very flattered by everybody's compliments, I appreciate it a great deal.
And we got a couple more questions before we wrap the interview up.
Cool.
There is someone who has a bit of confusion that they were taught that you don't apply voltage to components to diagnose them.
This is not.
Do you
applying
agree?
voltage.
They're not applying voltage to the
This is
component.
not, this is not applying voltage.
We'll answer it for them.
That's right, that's right.
What we're doing is, just to clarify, you're removing the component from the circuit and you're applying a load to the circuit. You're letting the circuit run through the meter, but you're actually applying a load to it so that
It's
if
a
the
dynamic
voltage
test.
drops, that will indicate that the circuit could not handle the current that's needed. But you're not actually applying a voltage to that component because the component's out of the circuit while you're testing
You're
it.
applying it
This is
to a
your load.
live circuit.
Right.
You know the other thing I think people are thinking of here, this is not a power probe.
No, it's not a power
It's not a power
probe.
probe.
It's totally different,
There's a different methodology here.
totally different. So I think some people, and I know there were some questions up there about that.
What you're doing on here basically is almost like putting a parallel load on the if you kept the load on there, all right, but it wasn't working, all right, and you back probed the load with this, all right, you can put another load on the circuit to make sure, or a paralleled load on the circuit to make sure there's no voltage drop in that circuit.
Is this similar to using the headlight bulb?
Yeah, same idea.
Same principle. Yeah.
Similar,
Yeah,
similar,
similar,
similar.
but just obviously for smaller circuits.
And it's not gonna, a headlight bulb could
Yeah.
put too much of a
That's correct.
strain on some circuits, this
Oh,
can't.
absolutely, right,
Yeah,
right.
Yeah.
Any other questions up there, Betty?
Do you actually have to remove the part from the circuit, or can you just load around it?
You can parallel it, you can load
Yeah, around.
around it,
Well,
absolutely.
wait a minute. Yeah, you can, but why would you? I mean,
Right.
the whole point of the tool is to act as a substitute load, so.
Absolutely.
Plus, you can confuse yourself if you have both of the items in the circuit.
Right, but if the load is open, if the load's not working and it's open circuit, then, but you're right, you should actually test the circuit itself.
Right, yeah, go back to the 80%, right? I mean, 80% wiring, so let's check that first. And every one of you out there knows that no mechanic, no technician wants to trace wires. Okay, well, the beauty of this tool is the only connection
Except him.
you care about is the one.
He loves it.
That's all Richie does, is wiring.
There's a question that hopefully you can answer. Can you use this with a DOS as well as a meter?
DOS.
Digital oscilloscope.
A scope, you could.
You could. Why not?
Sure.
Why not?
Yeah.
Yeah,
Well,
the
the
tool
circuit is the
modifies
same.
the circuit, the tool doesn't modify the meter.
That's right.
Yeah.
That's right.
Yeah, you're just gonna see a picture format of
Right,
it instead of a digital
You're just
format.
right, it's still gonna give you a reading, there's no difference.
Yeah. Yeah.
All the scope does is measure resistance anyway.
We've done it with the Modus, the Snap-on Modus thing.
there you go.
And there's another one that,
That's it.
I can't keep up with stuff, I got too much other stuff to do.
Probably a Verus.
Yeah, what it's doing is it's the
That's been
tool
happening.
is a substitute load, which means that you wouldn't have the original load in there. And when you push the button, it simply causes current to flow because you will not have a voltage drop unless current is flowing.
Unless that circuit is
And
wet.
and remember, when you throw in the ghost to zero voltage, right? I mean, people are not gonna good, game with that, but when you throw in ghost to zero voltage, that's automatically an open, and this is automatically a short to ground. And the importance to me is that it calibrates your eyeball, right? I want to know what I'm looking for. I don't want to just say the wire's bad. I want to say I have an open wire. I want to be precise because that calibrates the eyeball for what I'm looking for, and it kind of keeps me off the wild goose chases a little bit, and it just makes you focus a little bit more to know exactly what the fault is, and that's really what this makes possible.
Can I squeeze in one more question?
Sure, we have a couple of minutes more.
How can you rule out voltage drop on the ground or power side?
You switch the leads.
Okay. That was the previously asked question, but you always ask it wherever it was. Okay, here's the deal. If I have my basic circuit here, switch, fuse, battery, connector.
He's drawing this on.
Yeah,
For some of you that would be viewing this on YouTube, we'd recommend that you go to Dan's YouTube channel where he has probably a lot of this, because you're not seeing what we're seeing, you're just seeing us. Dan is drawing this on a piece of paper. to be viewed.
You're pretty much switching the leads from power side, and then you're going to the negative side.
Yeah, the reason they're called voltmeter leads is because you never take them off the voltmeter. All right, so there's your basic loop circuit,
Yep.
and we're checking for continuity by reading voltage. So if I see system voltage, then if I see system voltage,
With the button push,
you push the button, and if it stays system voltage, then we don't care. We're done. We go by a part.
Because it's
Right?
got
If I
good
see
power and
system
good ground.
voltage, right? That's where we say we eliminate opens and shorts. Now, if I look at this circuit right now and it drops to 2 volts,
you gotta chase power.
now what do?
Chase power back.
No, drop the black lead to ground. What will that do?
If you drop the black lead to ground, now you've fixed the ground
Yeah.
side. It cannot be on the ground side. So now if it still drops, it's on the voltage side.
Right, and now, that's exactly right,
I'm
but
ahead
add
of
the
it.
term, repeat the test, right? So the first test is the whole loop.
Yes,
The second test is only the positive side.
yep.
Between those two tests, it has to be one side or the other, and it's a process of elimination.
Actually, wait a minute, I'd like to amend that. I think you should always test both halves separately. What if you're not really getting the identical number, but you're in a rush, and you have some resistance on both sides? So I think maybe as a protocol, it would be a good idea to test both sides just in case you were being a little too fast and you really had 2 volts when you pushed the button the first time, and you had 5 volts that kind of looked to you in your dyslexic way like 2 volts when you did the power side, when you really have, half and half type of deal. You have some on the ground and some on the power.
Well, I don't object to that at all. There's certainly no flaw in that. My operational experience is I typically don't find multiple problems on a single circuit so far apart.
Except on
Doesn't mean it
flood
doesn't happen.
vehicles.
Flood vehicles with plows.
I think my philosophy, in fact, when I do this in the class. I put a fault in the positive, I put a fault in the negative. And I actually agree with you. It might be a good idea to load the ground side separately, because remember the probe has to go on the positive in order for this to work.
Right.
So you find a good positive, in fact, I'm trying to get Steve to put a jumper wire in to connect to the battery to give you a positive extension for ground testing. I'm not sure.
Small move.
You can just use a power probe for that. You can
Yeah.
power probe the power side.
Yeah,
Yeah, absolutely.
Or-
That would be,
or AES has a lead that'll clip onto the battery and go right there.
Right.
They have a bunch
Yeah.
of leads.
With a
I got
fuse
it.
in it.
yeah. There's
Fuse
no
lead.
perfect answer, but my biggest concern is that we have to get people thinking in the same line, essentially, and we're not doing that right now. We're not doing it through schools, we're not doing it in industry training, and we're not squawking because I get 47 different manufacturer manuals with 47 different ways to find a broken wire. And I do not understand that. I'm completely confused why after so many years, we have not ever done that. So, I don't know how to fix it, but I think we need to.
We've been trying.
We've been trying, and we appreciate having someone like you on as our guest, because you're trying to solve a problem that has been in our industry for years, Dan.
Yeah.
And,
If you will allow me, for those persons out there who don't have a meter, we've created this particular kit called the TMX 589, it's called Tech Meter. It comes with the meter, which is essentially what you need for everything. It comes with the leads, it comes with the book, it comes with a compass to diagnose alternators, and it comes with a 1-hour DVD that I produced on meter reading and diagnostics. And that whole kit is less than less than $300. So, this is another option for someone who's actually in the market for the whole shebang. And we just tell people to go on board the truck and ask for the TMX. That's the name of the meter. By the way, G, let me
Yes.
do this real quick before you go. How do you use a compass to diagnose alternator function?
Wow.
He had it I looked at it on YouTube the other day, so I can't ruin this, can I?
Okay, all right. All right, well, everybody needs to go out and buy a compass, because all you do is put a compass on the black lead of the battery, not the
Oh,
plug,
it's
the
gonna-
lead.
The lead on the wire.
Magnetic theory
Here's gonna pull it.
will spin the needle one way, and
Right.
then if the alternator's charging, the voltage in that goes up, the needle will spin the other way, and that proves that the alternator's charging at that particular moment. So in one crank, you can actually determine whether or not the alternator can produce sufficient voltage. Now, whether it pulls that voltage is another question,
Right.
but you can just leave the compass on the cable and watch.
Right. And he used it also to test solenoids very quickly. Is it really actuating? Very cool.
Yeah.
Very neat.
It rules out
Very
the
cool.
electrical
Yeah,
side
that's
pretty
what it is.
thoroughly, pretty quickly.
There's electrical action going on. You got.
It's
you got a
another reason
magnetic
to go to
flux.
your YouTube channel.
Yeah, there you go.
I didn't see that, I apologize.
By the way, when Jerry mentioned that we were doing this and suggested we look at your YouTube videos, I looked at a few of them. I thought that was very interesting with the compass.
Yeah,
Very cool.
unfortunately, I was working left and right, I had no time.
It's in your book as well.
Yeah, I know, but I read through his book quite a while ago.
Between that
But that's
tool
pretty-
and the compass, I could have fixed the plow in 3 minutes instead of 3 hours.
There you go. Speaking of which, my plow is messed up, and I'm hoping they'll have time to
You know,
diagnose it
we're
tomorrow.
running low on time, so B, any other questions that we can help everyone with? And again, we want to remind you to go to Dan Sullivan's site or go to YouTube and just type in Dan Sullivan.
There is a question about, regarding how far can you test on a vehicle from front to back? Not sure if you already answered that.
No, that's actually a kind of interesting question, because it's a voltmeter.
Yeah.
So,
Don't matter what it is.
I work on 400-ton coal trucks. I worked on dragline cranes, and the beautiful thing about the voltmeter is that you put it in your pocket and go all the way up to the end of a 200-foot boom
Right.
and check voltage. And that's really one of the other functional advantages is you're not tied to a battery. You're not required to have power to something in order to use
It's a
it.
big
You
advantage.
use the vehicle's power, which is what we're testing anyway.
That is a
So,
big, big advantage when you
yeah.
think of it.
It's a little bit simpler to use
Yeah,
in
bring
the
in power all
sense
the time.
that it doesn't start involving other power supplies, which you have to interpret. You're just interpreting the power supply on the piece of equipment, and it goes wherever your meter goes.
That is very good. And we thank everyone out there for asking all the questions. And once again, Dan, we'd like to thank you and we'll wrap up a TST roundtable here. Don't forget, tomorrow night, we have our live hands-on, on-car break night with Pete Meyer from Motor Age. So you'll see myself and Pete and Mr. Pierre. I make him volunteer for everything, whether he likes it or not.
I've been volunteered.
We'll see you then, and again, you will not see a lot of the stuff that Dan was drawing. I do want to remind you once again, you won't see that, but you can go to his YouTube channel, Dan Sullivan. So from TST headquarters here in New York, good night. Thank you again.
Thank you, good night.
Thank you.
Thanks, Dan.